Hi, my name is David, and this presentation is about my analysis of employee attrition and salary using the employee dataset. So here, I was able to examine job roles with the highest average environment satisfaction. And so as this bar graph shows, we see that manufacturing directors have the highest average environment satisfaction at a score of 3. And research directors on average have the lowest environment satisfaction at 2.45. Again, I was able to analyze the highest average job satisfaction for each job. So as we see, healthcare representatives have the highest average job satisfaction of 2.83, and research directors have the lowest average job satisfaction at 2.49. So again, as we see in these two graphs, research directors have the lowest average job satisfaction and lowest average environment satisfaction. So I also analyzed job roles with the highest average number of years at the company. So as shown in the graph, managers have the highest average number of years at 13.78, and sales representatives have the lowest average number of years at 2.92 years. So these three graphs are sort of a segue into my next analysis, which was classifying attrition. So in order to do so, I used something called naive Bayes classifier. So naive Bayes is a statistical theorem, which allows us to calculate the probability of event A occurring given that event B has occurred. So if we had many events like x1, x2, all the way through xn, we would be able to calculate the probability of event Y given that event x1, x2 through xn have occurred, as shown in the second formula. So I used the naive Bayes classifier on the employee data set, and I split the data set into a training set and a test set. Training set consisted of 70% of the data set, and the test set consisted of 30% of the data set. So I was able to use all models, all variables, excuse me, in my naive Bayes model. And the model ended up having an 85% accuracy score. So accuracy in this case would mean the total number correctly classified divided by the total number of observations, which is very high. 85% is very high. We also have a sensitivity of 88% and a specificity of 71%. So sensitivity is the total number correctly classified as no divided by the total number of true no's. Specificity is the total number correctly classified as yes divided by the total number of true yeses. So for predicting year salary, I was able to use a linear regression model in order to predict salary using certain variables in the data set. So I manually dropped some variables, including employee count, over 18, standard hours, and monthly income. So employee count over 18 and standard hours only had one particular outcome. And so my linear regression model was not useful in being able to use those to predict salary. So I dropped them. Monthly income, however, was used to calculate salary, and so I dropped it. And so in order to drop additional variables that were statistically insignificant, I used something called stepwise selection, which only chose the models when added that were statistically significant or had a p-value that was less than 0.05. After that, I split the data set again into a training and a test set, 70% of the data set was the training set, and 30 was test. And so from the model, the final model that I chose that had the lowest root mean squared error and the highest R squared included job level, job role, total working years, business travel, distance from home, years with current manager, and years since last promotion. And so what we were able to find was that the root mean squared error on the training set for salary was $12,000 approximately. The root mean squared predicted error that was found on the test set compared to the true salary numbers was also approximately $12,000. And so we were able to find an R squared of 95, about 95%, which means that an estimated 95% of all variation in salary is explained by these seven variables. So thank you for your time, and if you have any questions, please feel free to contact me. Thank you.